Under a merciless sun on a nameless Pacific island, the air rippled with heat and decay. It was June 1944. Jungle vines hung like twisted veins over the mangled wrecks of trucks and tanks, and the smell of rot, of men and machinery, settled thick on the breathless wind. Japanese infantry, their uniforms bleached pale by sun and sweat, stumbled through ankle-deep muck. Their canteens were empty. Their tongues, swollen from dehydration, scraped against cracked lips as they scooped muddy water from a stagnant swamp. The liquid shimmered green with insects. It reeked of decay, but it was life, or at least a chance at it. Imperial Japanese Army Medical Log. June 1944, miles away, behind the American line. A different sound echoed. The rhythmic hum of engines, the hiss of steam, and the clatter of tools against metal. U.S. Army engineers clustered around a series of cylindrical units mounted on half-tracks, steel machines that gurgled and churned like something alive. The soldiers called them miracle wagons. Within them, seawater, swamp water, and even blood-stained puddles could be turned, almost alchemically, into something pure, something clear, something vital. Drinkable water. U.S. Army Quartermaster Corps Field Report, 1944. The Japanese soldiers had no such luxury. For them, water had become as elusive as victory. By 1944, Japan's Pacific Empire was bleeding dry. Convoy routes were shattered by submarines. Supply ships went down under American bombs faster than they could be built. Entire garrisons, from New Guinea to the Marianas, were left to wither. Without clean water, the body collapses. The mind falters. Discipline breaks. Yet, in the thick jungles and volcanic ridges, their officers demanded endurance beyond human limits. Post-war medical analysis. U.S. Army Medical Department. 1947. On the island of Saipan, U.S. Marines advancing inland found dozens of Japanese canteens filled with cloudy liquid, some with worms floating inside. Prisoners spoke of drinking from puddles next to decomposing horses. One soldier's diary read simply, "Water gone. Tongue like sandpaper. Death tastes like this." Captured diary, Saipan, July 1944. Meanwhile, the Americans were carrying their own rivers. Since late 1942, the Quartermaster Corps and the U.S. Army Corps of Engineers had been quietly developing portable purification systems, compact, rugged, and adaptable to any terrain. Born from the laboratories of the U.S. Army Medical Research Unit and refined in workshops across Detroit and Chicago, these units used chlorination, filtration, and boiling under pressure. The smallest, the Lister bag, could purify 36 gallons at a time. The larger mobile units, mounted on trucks, could supply whole battalions. Technical Bulletin QM 5-24, 1943. On paper, it was a small advantage. In reality, it was revolutionary. In the Pacific, disease killed more men than bullets. Dysentery, malaria, and dehydration were constant predators. For every man who died in combat, another collapsed from infection or thirst. The American solution, simple, mechanical, industrial, quietly flipped the balance. Every purified gallon meant one more soldier who could march, shoot, dig, and survive. Army Epidemiological Study, 1946. Japanese units resorted to boiling water in battered helmets or filtering it through strips of cloth. It helped little. Fuel was scarce, time scarcer, and the water itself, drawn from swamps tainted by corpses and rotting vegetation, was deadly. American observers after the war noted that as many as 60% of Japanese casualties in some island campaigns stemmed from preventable diseases linked to contaminated water. U.S. Army Pacific Command Medical Survey, 1945. In contrast, American GIs remembered the taste of their purified water as the taste of home. Soldiers joked that they carried entire lakes in their trucks. But beneath the humor was a quiet awe at what modern engineering had achieved. The quartermaster engineers, men like Major Carl Rogers Darnall, whose pre-war work on chlorination became the backbone of the system, rarely saw the front lines. Yet their inventions marched beside every rifle, every ration, every drop of life. Biographical note, Major C.R. Darnall, Army Engineering Journal, 1945. By 1944, this technological edge extended across the Pacific. On Guam, American Seabees erected desalination plants within days of landing. On Leyte, mobile purification trucks followed Patton's logistics doctrine to the letter. An army marches not only on its stomach, but on its canteens. Quartermaster Field Notes. October 1944. The result: steady hydration, steady morale, steady victory for the Japanese. It was the opposite. Their supply lines strangled, their water sources fouled by combat and climate, their morale eroded with each gulp of swamp water. Reports from captured officers describe hallucinations, mass dehydration, and men fainting under the sun while trying to refill canteens from puddles filled with larvae. The enemy fights with machines, one officer wrote. But the cruelest of them all is his machine for water. The difference was invisible to the eye: no bombers in the sky, no roaring tanks, but its impact was immense. Clean water sustained operations. It allowed medics to sterilize instruments, cooks to prepare rations safely, and engineers to mix concrete for airstrips. It kept the American machine of war lubricated not just with oil, but with life itself. Every drop of purified water was a weapon, quiet, unseen, but devastating in its strategic weight. U.S. Army Logistics Review, 1945. By the end of 1944, as Japan's outer defenses crumbled, American logistics had become an unstoppable tide. Mobile purification units rolled ashore with every invasion fleet. Some could produce 1,500 gallons per hour, enough for an entire regiment. Each was staffed by trained water technicians, many from industrial plants back home who'd volunteered for military service. Men who once maintained municipal water systems in Chicago or Philadelphia now worked under fire on coral beaches. They were unsung heroes, technicians of survival. Engineering Corps Oral History, 1948. In the jungles beyond, Japanese soldiers watched the Americans move effortlessly through terrain that had once killed invaders by disease alone. How could they fight an army that carried its own clean rain? How could starvation and thirst be weapons when their enemy had found a way to abolish both? It was a quiet revolution, unseen in the thunder of artillery, but decisive in outcome. As General MacArthur's forces prepared for the return to the Philippines, logistics officers calculated that mobile purification would cut non-combat casualties by nearly 40%. It meant stronger troops, fewer evacuations, longer campaigns. The U.S. could push forward relentlessly, while Japanese forces dwindled in both number and strength, defeated not just by bullets, but by biology, chemistry, and engineering. U.S. Army Pacific Engineering Memo, 1944. Night fell over the Pacific outposts, and the two armies lived in different worlds. For one, the silence of dying men beside foul pools. For the other, the steady hum of filters, the hiss of steam, the cool taste of water that smelled faintly of chlorine. Clean, safe, and endless. By the time the Americans landed on Iwo Jima, the balance was absolute. Japanese soldiers crawled through volcanic ash, desperate for a sip of anything. American GIs filled their canteens from gleaming steel tanks. The war for hydration had been won long before the battle for the island began. And yet, hidden behind the quiet efficiency of those mobile units, lay a deeper secret, a piece of technology so advanced, so quietly deployed, that few outside the Corps even knew it existed. It would redefine survival itself in the Pacific Campaign, in the sweltering jungles of the Pacific. The secret advantage that kept American troops alive was not merely the Lister bag or the basic filtration trucks. It was a system born from the intersection of chemistry, logistics, and wartime innovation. Behind the curtain of the battlefield stood a machine that could turn death into life. The Army Mobile Water Purification Unit Model 600 GPH. A compact, pressurized marvel capable of rendering even seawater safe to drink. Designed by the U.S. Army Corps of Engineers in partnership with General Electric and the Carrier Corporation, it became the lifeline of advancing divisions. Technical Manual TM 5-227, 1943. Its process was deceptively simple: pressure, heat, and chlorine, but its reliability under chaos made it legendary. Each unit weighed roughly 2.5 tons and could operate continuously for 72 hours with minimal maintenance. It used a three-phase diesel pump to force contaminated water through layered sand and activated charcoal filters, followed by chlorination chambers calibrated to within 0.2 parts per million. The result: crystal clear water that met civilian health standards even in the heart of war. Quartermaster Engineering Report, 1944. While the Japanese struggled with rusted canteens and tainted puddles, the Americans brought chemistry to the battlefield. Engineers like Captain Charles F. Sawyer and Dr. Henry Darnall, a descendant of the man who pioneered municipal chlorination, oversaw the redesign of earlier prototypes to survive the salt, sand, and shock of Pacific combat. The result was a machine so rugged it could be dropped from a landing craft and still function within an hour. Army Corps Experimental Unit notes, 1943. To the Japanese observers, it seemed impossible. American units never seemed to run out of energy or endurance. Prisoners later spoke of watching U.S. engineers bathing in clean water after battle, while their own men licked dew from leaves to stay alive. They were machines, one recalled, men of iron and water. The first major test of this system came not on Saipan or Iwo Jima, but in the Battle of Biak, May 1944, a volcanic island off New Guinea's north coast. There, under the command of General Robert L. Eichelberger, U.S. troops faced brutal resistance and suffocating heat. Temperatures soared above 100 degrees Fahrenheit. The Japanese, entrenched in coral caves, poisoned every freshwater source they could find, flooding wells with salt water or corpses. For the average infantryman, dehydration set in within hours. Southwest Pacific Area Command Log, May 1944, but Eichelberger's men carried an edge. Within 48 hours of landing, U.S. engineers set up 3 Model 600 units near the beachhead. Pipes snaked through the sand, drawing seawater directly into the machines. Inside the metal drums, pumps thundered and steam hissed as filters did their work. The purified water gushed out, cold and clean, into 55-gallon drums marked with white stencils. Safe. U.S. Army Water Supply. Bureau of Sanitation Report. 1944. Each soldier received a full canteen every morning, refilled again at dusk. Field medics washed wounds with sterilized water instead of swamp runoff. Mortar teams doused hot barrels between fire missions. Cooks rehydrated powdered rations that would have otherwise been inedible. By the 4th day of combat, American casualties from dehydration were near zero, an unthinkable figure in that climate. The Japanese, meanwhile, began dying faster than they could be buried. Army Medical Survey, Biak Sector, 1944. The enemy's reaction bordered on disbelief. Intelligence intercepts revealed urgent memos demanding to know how the Americans conjure water from the sea. One surviving Japanese officer, interrogated months later, described hearing the constant humming of a beast near U.S. camps at night. Machines that seemed to drink the ocean and breathe it back as life. Behind that beast was relentless American engineering discipline. Each purification unit was manned by a 5-man crew trained at Fort Belvoir, Virginia. Their duties ranged from chemical testing to pump repair under fire. If a machine broke down, a replacement part could be fabricated on-site using portable welders. Soldiers carried chlorine test kits, small glass vials, rubber droppers, and reagent tablets to monitor purity every 6 hours. Engineer Training Circular No. 7, 1944. On June 4, 1944, as Biak's cliffs trembled under naval bombardment, U.S. troops pushed inland with full canteens. The Japanese, desperate, made night raids on water drums, losing men to sniper fire for a few mouthfuls of liquid. In one skirmish, 24 Japanese soldiers died charging a purification truck, mistaking it for an ammunition vehicle. Combat Intelligence Debrief, 41st Division, 1944. The American advantage wasn't just survival, it was sustainability. A typical division of 15,000 men required over 30,000 gallons of water per day for drinking, cooking, and sanitation. With the Model 600s and Lister bags combined, that demand could be met indefinitely, independent of natural sources. Logistics officers could plan offensives without worrying about rivers or wells. It was a new kind of freedom, industrialized self-sufficiency on the move. Quartermaster Logistics Manual, Volume 3, 1945. The Japanese lacked such independence. Their supply ships were under constant threat, and their water stores often spoiled in tropical heat. Metal canteens corroded, and bamboo containers split. They resorted to digging shallow wells. often contaminated by runoff from decomposing bodies or latrines. Japanese medical officers noted that 70% of frontline troops on Biak suffered from dysentery or amoebic infections by the third week. Imperial Army Medical Division report, June 1944. In contrast, the Americans grew stronger the longer they fought. Their hydration meant fewer cases of heat stroke, steadier aim, and quicker reflexes. Water wasn't just about comfort. It was performance, endurance, and willpower. A hydrated army, one engineer later wrote, is an invincible one. Quartermaster Technical Review, 1945. The success of Biak was followed by refinements. Engineers modified the Model 600's intake screens to resist volcanic ash at Purification. The Carrier Corporation adapted its refrigerant compressors for the pumps, while Dow Chemical improved chlorine tablets to last longer in humidity. Each innovation built upon another, an evolving organism of technology. Industrial Collaboration Notes, 1944. Meanwhile, Japanese officers issued frantic orders to dig reservoirs and capture rainwater, but it was too little, too late. Their soldiers' skins split from salt loss. Their lips bled. Entire companies surrendered simply because they could no longer stand. One prisoner, delirious from dehydration, reportedly asked an American medic if he could taste the machine that made the clean water. By mid-1944, the Americans had standardized portable purification systems across the Pacific, from New Guinea to Guam. The logistical chain for water became as vital as ammunition. Engineers rode with infantry columns, and every landing plan included dedicated water platoons. On invasion charts, next to artillery and fuel dumps, stood the new designation, Water Point, Purified, Army Amphibious Operations Manual. 1944, the effect was invisible yet total. American troops could fight longer, recover faster, and move farther inland without pausing to search for drinkable sources. It turned jungles that once swallowed armies into manageable terrain. It gave commanders the most valuable resource in wartime. In Tokyo, High Command began to notice. Reports from Biak, Guam, and later Purification carried the same refrain. Enemy troops unaffected by thirst. Strategic analysts concluded that superior resource purification was a factor of increasing concern. It wasn't just an observation, it was an admission of defeat on a microscopic, molecular level. Captured Operations Memo, Imperial GHQ, August 1944, but the water unit's real impact went beyond chemistry. They symbolized the American war philosophy, science as weapon, industry as soldier. For every rifleman, there was an engineer. For every tank, a technician. For every drop of swamp water, a mechanism is waiting to turn it into life. And as the war pushed toward the Philippines and the blood-soaked shores of Iwo Jima, that philosophy would prove unstoppable because the battle for water was only the beginning. The true power of this engineering edge would soon ripple across entire campaigns, reshaping logistics, morale, and the psychology of war itself. The Pacific burned beneath the weight of endless war. But in its inferno, the quiet triumph of engineering became one of the most decisive and least remembered victories of the 20th century. By 1945, the United States had achieved something no army before it had managed: complete hydration independence. From the steaming jungles of the Philippines to the volcanic deserts of Iwo Jima, American troops no longer fought the environment, they commanded it. U.S. Strategic Bombing Survey, 1946. Each mobile purification unit was more than a machine, it was a symbol of industrial might. The Quartermaster Corps called them liquid lifelines. To the men on the ground, they were miracles on wheels. The U.S. Army had built a war machine that could manufacture not only bullets and fuel but also water, on demand, anywhere on Earth. In an age where armies once marched or died by rivers, this was evolution made steel. Quartermaster Review, April 1945. The Japanese, by contrast, were broken not only by the loss of territory but also by the slow collapse of the human body. Reports from the remnants of the Imperial Army tell of hallucinations, men driven insane by thirst, and others collapsing mid-charge, their bodies too dry to bleed. "We were defeated by thirst before bullets," one survivor wrote years later. But the power of purified water reached deeper than biology. It struck at morale. American GIs knew they could rely on a system that never failed. Their canteens filled daily, their rations cooked safely, their medics confident in sterile conditions. A soldier who trusts his survival machine fights without hesitation. That trust multiplied across divisions until it became invisible armor, a psychological shield as strong as any steel helmet. Army Behavioral Analysis Division, 1947. In contrast, Japanese morale eroded with every sip of foul, green water. Captured diaries revealed the torment. Our mouths are full of mud. The enemy drinks clear water. Even the gods have abandoned us. Each gulp of swamp water reminded them of technological inferiority, of an empire stretched beyond the limits of its science. Imperial Medical Record, 1945. Strategically, the American mastery of water purification transformed logistics. Before 1943, tropical operations had been restricted by supply lines and the fear of disease. After 1944, those barriers evaporated. Entire task forces could establish beachheads without waiting for freshwater deliveries. Engineers simply unloaded purification units alongside jeeps and artillery. Within hours, an artificial river system, clear, safe, infinite, was operational. Pacific Theater Engineering Command, 1945. The effect on momentum was profound. Campaigns that would have stalled for weeks due to illness or exhaustion now advanced seamlessly. In the Philippines, General MacArthur's engineers used purification trucks to sustain entire corps through monsoon floods. At Leyte, amphibious operations continued through torrential rain because soldiers could drink from puddles filtered and sterilized on-site. The line between human endurance and machine endurance blurred. U.S. Army After Action Report, Leyte, December 1944. Behind this success were thousands of unsung engineers, welders, and chemists. In Chicago's factories, workers in denim and goggles assembled the same filters that would one day save Marines on Polilliu. At Dow Chemical, chemists refined chlorine compounds stable enough to survive jungle humidity. At Carrier, refrigeration engineers converted their cooling compressors into high-pressure pumps. These civilians never heard the roar of battle, but their hands built the quiet machines that let others fight, drink, and live. War Production Board Report, 1945. In Iwo Jima's Black Sands, the difference between life and death was sometimes a single gulp. American purification units ran constantly, their diesel engines muffled under tarps to avoid drawing fire. Each drum of clean water was a victory in itself. Medics sterilized scalpels. Radio operators mixed coolant with pure water to prevent short circuits. Mechanics washed volcanic grit from tank treads. Every part of the war machine was nourished by those filters. Bureau of Engineers Combat Log, Iwo Jima. 1945, by the war's final year. The United States had 1,200 mobile purification units in active service across the Pacific and Europe combined. Together, they produced over 12 million gallons per day, enough to sustain an army of over 500,000 men. Army Quartermaster Logistics Summary, 1945. That number wasn't just arithmetic. It was destiny. Where ancient generals marched toward rivers, American commanders created them. The terrain itself no longer dictated the limits of human movement. When the war ended, the psychological echo lingered. Post-war interrogations of Japanese officers revealed a haunting realization. They had underestimated not just American firepower, but also its fusion of science and logistics. One general, reflecting years later, remarked bitterly, "The enemy conquered the elements themselves." U.S. Strategic Intelligence Interrogation, 1946. The victory reshaped military doctrine. In the early Cold War, NATO forces adopted this self-sustaining unit model, ensuring every division carried its own purification capacity. In Korea, mobile purification units prevented the kind of disease outbreaks that once crippled armies in similar terrain. By Vietnam, portable reverse osmosis systems, direct descendants of those 1940s designs, had become standard. Army Technical Evolution Bulletin, 1963. Even in modern conflicts, the Gulf War, Afghanistan, Iraq, the lineage continued. Engineers still trace the roots of today's compact reverse osmosis systems to the Pacific prototypes of 1943. The principle remained the same: Survival through autonomy. When the terrain denies you life, make it yourself. U.S. Army Corps Modern Systems Report, 2003, Beyond the Battlefield. These wartime technologies reshaped civilian life. The same chemical principles and mechanical designs found their way into municipal water systems, disaster relief equipment, and humanitarian aid programs. Every modern water purification tablet and every portable filter used by hikers or disaster responders carries the DNA of those World War II innovations. The machinery that sustains soldiers became the machinery that sustains humanity. National Sanitation Foundation Historical Review, 1975. Yet amid the triumph, the cost was human. Thousands of Japanese soldiers perished not by bullet or bomb, but by thirst. Their deaths were slow, silent, and invisible to history's loudest pages. They fought with valor but were betrayed by an empire that had prioritized glory over science and obedience over innovation. In the end, the war's most merciful weapon was also its most unforgiving: clean water that one side possessed and the other could only dream of. Post-war Japanese Medical Reconstruction Study, 1948, in the grand calculus of World War II, where steel, oil, and firepower are often glorified, the war for water remains hidden beneath the waves of memory. Yet it was this invisible current, this triumph of filtration and chlorination, that quietly reshaped the arc of empires. Without it, victory might have turned to stagnation, conquest to collapse. A.S. dawn broke over the ruins of the Pacific. An American engineer, his uniform stained with grease, not blood, watched his purification unit hum beside a captured beach. Around him, soldiers filled canteens, laughing through exhaustion. The machine rattled, hissed, and breathed. It had no medals, no name, no monument. But it had done what no weapon ever could. It had defeated thirst itself that he scribbled in his field notebook before shutting it forever. In this war, it wasn't just who fired first. It was who could drink first. Because in the modern age of total war, survival is no longer written in courage alone. It is written in chemistry, in engineering, and in the will to make life where death should reign. And as history proved in the jungles of the Pacific, connection outweighs firepower, and life flows to those who can create it.